So today's lesson, it builds off of the lesson from last week on Thursday. So if you haven't watched that video, make sure you go back. I talked about the difference between an expression and an equation. Now today we're going to go a little bit more in depth about expressions. Tomorrow we're going to talk about equations. So remember, an expression is just a combination of numbers, variables, and operations. So you could have like 3x plus 4, that's an expression. There's no equal sign. Okay. Now, one thing when we're dealing with expressions is we can use this term called simplifying. The three things that we're going to talk about for simplifying an expression are the distributive property, rearranging terms, and combining like terms. So the first thing we're going to talk about when we're simplifying expressions is the distributive property. Now, you've probably seen this before, but the distributive property looks like when you have a situation that looks like this. So you have a number, I just put n to represent any number, and it could also be a variable. It doesn't have to be a number, it could be an x or a y as well. But you have something on the outside of parentheses, and then something else being added on the inside of parentheses. Now, I have two things being added here, a and b, but I could really have as many things as I wanted to. But the distributive property will still apply. So the distributive property says that when you have something multiplied outside of parentheses with some things being added on the inside, okay, it's got to be addition or subtraction, okay, then you can distribute the factor on the outside to each of the terms on the inside. So each piece that's being added is called a term. This is a factor because it's being multiplied. You can distribute the factor to each term because of the distributive property. So the way that I usually show this is by drawing arrows. So we can say that we can distribute the factor to each term. So we can distribute this n to this term a, and then we can distribute the n to the term b, and we can get rid of the parentheses to simplify the expression. So we would have n times a, so I'm going to write it like this in parentheses, or you could just write na, but I'm going to use parentheses to separate them, plus n times b, which is like that. So this gets rid of parentheses, which in some problems will help us to solve it a little bit easier. Here are 4 examples of problems where you can use the distributive property. I want you to pause the video and try them on your own first, and when you're ready, press play and I will go over them. So on number 1, we have a number on the outside, which is the number 4, and inside of the parentheses we have 2 terms. We have the term x and we have the term 3. So the distributive property says we can distribute the 4 to each of the terms. So we're going to distribute the 4 to the x, and we're going to distribute the 4 to the 3. So 4 times x is 4x. Whenever you have a number and a variable, you just write them right next to each other. Then we have a plus in between, and then we have 4 times 3, which is 12. So that's the solution for number 1. For number 2, we have a negative 2 on the outside of the parentheses, and we have 2 terms on the inside. Even though we have a subtraction instead of an addition, it's still 2 terms. So we have the term x, and we have the term 2. Now you've got to be careful when you have negative numbers, or when you have minuses. Works a little bit differently. So I'm still going to distribute the negative 2 to each term. And I'm going to have negative 2 times x, that's negative 2x. And I have a negative 2 times a minus 2. So when I have a negative times a negative, double negatives become a positive. So negative 2 times negative 2 is a positive 4. So the solution for number 2 is negative 2x plus 4. And the reason it's a plus is because of the 2 negatives. They become a positive. Now number 3 looks a little bit different. First of all, one of the biggest differences is that inside of the parentheses, we have 3 terms. We have x squared, we have 2x, and we have 16. So we have 3 terms this time, so we're going to distribute 3 times. The other difference is we only have a negative sign on the outside, So what's important to understand here is that when you have a negative sign with nothing next to it, you can imagine this as being like a negative 1. Okay? Sometimes, just like when you multiply by 1, you don't have to write the 1. So it's the same thing with a negative 1. You don't have to write the 1. You can just put a negative sign and it means the same thing. So I'm going to be distributing negative 1 to each term. So I'm going to multiply each of these 3 terms by negative 1. Now, one thing about multiplying by negative 1, multiplying by negative 1 just changes the sign. So if it originally was positive, it becomes a negative. And if it was originally negative, it becomes a positive. So my positive x squared is going to become negative x squared. Okay? You can write the negative 1 if you want, but it's not necessary. Negative x squared means the same thing. A plus 2x, because I'm multiplying by negative 1, is going to become a minus 2x. And a minus 16, because I'm multiplying by negative 1, it changes the sign, it becomes a plus 16. So that's the solution for number 3. And for number 4, the difference here is that we have a variable on the outside instead of a number. On the inside, we still have 2 terms, x and 3. Now, even though we have a variable, we still do the things the same way. But that means what's going to happen is we're going to distribute the x to each term. So we're going to multiply x times x and x times 3. So you have to know how to multiply variables in Algebra 2. X times x, this is x, we don't write it, but it's x to the first power and x to the first power. When you multiply 2 variables with the same letter, so we have 2 x's and you multiply them, you add their exponents. So 1 plus 1 is 2, so x times x is x squared. And then x times 3, we always write the number in front, so it's going to be 3x. So the answer for number 4 would be x squared plus 3x. The second thing we can do in simplifying expressions is rearranging the terms. So that means we can change the order that the terms are listed. The reason we can do this is because of the commutative property. The commutative property just means that when you're adding a bunch of things, the order does not matter. So in this one right here, I wrote a plus b is equal to b plus a. Doesn't matter the order that you write 2 things being added, they stay the same. When we rearrange the terms, we want to put them in decreasing order from left to right by their exponents. So we're going to have variables, like we might have a bunch of x's, that's the most common thing, and they're going to have exponents. So we might have x to the 5th power, x to the 3rd power, x squared, just an x, etc. We're going to put them in decreasing order, so the highest exponent all the way to the left, and they're going to decrease all the way to constants all the way at the right. And then the last thing to keep in mind when you're rearranging terms is that you have to keep the negatives with the terms. So if you have a minus, you keep it negative, because when you subtract something, like if I was subtracting 2, that's equal, it's the same thing as adding a negative 2. So if there's a minus in your terms, when you rearrange things, you keep the negative with that term. So I want you to try to simplify these 2 expressions by rearranging the terms based on what we just talked about. Go ahead and pause the video, and when you're ready, press play and we'll go over the answers. So for number 1, 2 main things we got to look at. What are the exponents, and are there any negatives? So first thing we need to do, first we have this 3. Well, 3 is a constant, there's no variable, so the constants always go at the very end. So I know my 3 is going to be my last thing. Then I have a negative 4x. When there's no exponent, we can imagine that the exponent is a 1. Okay, if there is no exponent written, that means the exponent is a 1. So we have an exponent of 1, and then we have an x squared, which has an exponent of 2. So we want these in left to right in decreasing order. So we want the highest exponent to the left, decreasing all the way in constants on the right. So x squared is our highest, so that's going to be our first term. Now this is a plus x squared, so it's going to be a positive x squared. Our next highest is the x to the first power. Now be careful because this is a minus 4x, so I have to keep the negative with this term. So I'm going to have a minus 4x. And then my constant is a positive 3, so I'm going to have a plus 3 all the way at the right. So on example 2, we're doing the same thing. We have to look at the exponents. We want to put them in decreasing order from left to right, where the highest exponent's on the left and constants are on the right. So if we look here, we have an exponent of 2, we have an x squared, we have an exponent of 5 on this term, x to the 5th power, we have a constant, negative 8, and we have an x to the 3rd power on this last term. So our highest exponent is 5, so we're going to put this one first. Now it's a minus 4x, and we have to keep the negatives when there's a minus. So the minus 4x, that's going to be the first term, so it's going to be a negative 4x, and we put it in front. So we have negative 4x to the 5th power. Then we decrease our exponent. So our next highest exponent is x to the 3rd. It's a plus 3x to the 3rd, so we're going to keep the plus. Plus 3x to the 3rd power. Our next highest is 6x squared. It's a positive 6x squared, so we're going to have a plus 6x squared. And that leaves us just with the constant, which is a negative 8, a minus 8. So we're going to have at the very end, minus 8. So this is the simplest form of this expression. These two expressions are equal. They mean the same thing. We just rearrange them in a way where the exponents are decreasing so it can be in simplest form. The third technique for simplifying expressions is combining like terms. Now you should have seen this before, but I'm going to break it down again. So combining like terms, so when we talk about like terms mean, remember terms are the things that are being added. Like terms mean they have the same variable with the same exponent. So two terms that have, let's say, an x squared, so they both have an x to the 2nd power, those would be like terms. When you combine like terms, you keep the exponent and you add the coefficients. So the number in front of the variable, if we had 3x squared and 2x squared, you keep the x squared, but you add the coefficients. So 3 plus 2 is 5. And then the last note here is that constants are always like terms. So if you have more than one constant, you can always combine those together. So same idea, here are two examples of simplifying the expressions by combining like terms. Go ahead and pause the video and try them on your own. And when you're ready, press play and we'll go over them. So for number 1, first thing we need to do is identify the like terms. So remember, if they have the same variable with the same exponent, they are like terms. So in this case, we have an x squared right here and an x squared right here. They both have the same variable x with the same exponent, with the exponent of 2, so we can combine those together. Now, when there's no coefficient written in front of it, what we can imagine that's there is a 1. This is like multiplying by 1. Multiplying by 1 doesn't change anything, so that's why we don't write the 1. So this is like saying 1x squared and 1x squared. Now we can combine those two by adding their coefficients. So 1 plus 1 is 2, so we have 2x squared when we combine them. We also have an x with an exponent of 1. Remember, when there is no exponent, it's like there's an exponent of 1. So we have a 3x and we have a 5x, so these two are going to be like terms as well. So when we combine them, we add their coefficients. 3 plus 5 is 8, so we have 8x. And we have some constants. We have a plus 3 and a plus 6. Both of those are constants, so that means they're like terms. 3 plus 6 is 9, so we can add those together and combine them. So the simplified form of this expression on number 1 is 2x squared plus 8x plus 9. For number 2, we have a 2x squared, which has a variable of x and an exponent of 2. And we also have a minus x squared. So same thing as before, when there's no coefficient, we can imagine there's a 1 there. So this would be like minus 1x squared. So we have 2x squared minus 1x squared. 2 minus 1 is 1. You don't have to write the 1. So you get x squared. You can put a 1 in front if you wanted to, but it's not necessary. Then we have a 5x and a minus 4x. They both have a variable of x with the same exponent. So we can combine those two by adding their coefficients. A positive 5 plus a negative 4 is a positive 1. So again, you can write the 1 if you want, but it's not necessary. So we just have 1x. And then we have some constants. We have a plus 3 and a plus 2. Combine those. 3 plus 2 is 5. So the simplified version of number 2 is x squared plus x plus 5. So here's the last example for today's lesson that I want you to try. So pause it and try it out, and then we'll go over it. Now here's a hint. It's going to require everything that we just talked about, all 3 of the steps. Alright, so when I look at this, I need to think about what's the first thing I can do. Now, we've talked about distributive property, rearranging the terms, and combining like terms. Now, right now, we have a term that's a 6. We have a term that's x times x plus 4. This entire thing is one term. Terms are separated by plus signs or minus signs. So we have a plus sign here and a plus sign here. So this whole thing is a term. We have a term that's 5x, and we have a term that's negative 10. Now, there's multiple ways that you could have started this. Maybe you wanted to combine the like terms first, so you could combine 6 and negative 10. Maybe you want to rearrange it first. It doesn't really matter what order you do it, as long as you're doing the things correctly. The way that I would start is to get rid of the parentheses. I don't like having the parentheses here. It makes things difficult. So I'm going to get rid of those by using the distributive property. Now, inside of the parentheses, I have 2 terms, x plus 4. Those are my 2 terms. And I've got an x on the outside of the parentheses. So I'm going to distribute the x to each term. That way I get rid of all of the parentheses. So x times x is x squared. X times 4 is 4x. So now I don't have any parentheses anymore, and I can bring everything else down. Now I don't have 4 terms anymore. Now I have 5 terms. I have 6, x squared, 4x, 5x, and minus 10. So again, the order that you do things is kind of up to you. At this point, maybe you want to rearrange them and put them in order from highest exponent to lowest. Maybe you want to combine like terms. I'm going to combine like terms next. I just like to have as few terms as possible, so I'm going to combine like terms. So I have an x squared, but I have no other x squared, so there's nothing to combine it with, so it just stays x squared. Okay, I have a 4x, which is just an x with an exponent of 1, and I have a 5x, which has an x with an exponent of 1. So I can combine these two together. 4x and 5x, 4 plus 5 is 9x. And then I have a 6 and a negative 10. 6 and negative 10 combine. 6 plus negative 10, or you could do 6 minus 10, is negative 4. So we would have a minus 4. Now, I kind of did this in an order that would put it in rearranged form, in simplest form. But if you did not have x squared and then x and then a constant, you would have to rearrange it to put it in that order as well. So this concludes today's lesson. There's no assignment for today, but there will be tomorrow that combines today's lesson and tomorrow's lesson. So be on the lookout for that. Make sure that you're getting your missing work done. If you have questions, let me know, and I'll be glad to help you.